So there are three types of LOD expressions that can be included in the visualization, and those three types are the fix, the include, and the exclude expressions. They have different purposes, and as I mentioned, level of detail expressions, they are used when we want to make aggregations on some dimension that might not be present in the view that we are creating. Okay, so in the visualization, we do not have that dimension, but we want to analyze data across that dimension. In three ways we can do that, using the fixed LOD expressions, the include LOD expressions, and the exclude LOD expressions. So include and exclude allows to go at a more aggregate level either, or at a more granular level than what is present in our visualization. Fixed LOD just fixes its value around the particular dimension on which we are computing the values. So again, let's take a simple let's create a simple bar chart and try to understand, or just create a simple table and try to understand. So we are going to use the sales figure. So we have sales over here, and now let's analyze it by, let's say, the categories and subcategories. So we have let's say a hierarchy over here, categories and subcategories. Okay, so now we have split the sales figures by categories and subcategories, and we're just going to make it a simple simple table so that we can view the values. Okay, and just bring the sales over here, and it goes back to being okay. Okay, so now we have these sales values which are which have been summed up automatically by Tableau, and they are at a level which is shown in the visualization. So they are summed up at the level of category and subcategory. So they are basically at a level of subcategory, because subcategory is one of the dimensions that we have in the view. But let's say we want to have some dimensions either up or down the granularity that is present in this view, or fix it across one of the dimensions. So let's create some LOD expressions. Let's create all three kinds of LOD expressions in this case, fix LOD, include LOD, and exclude LOD, and see how these results vary for the three kinds of LODs that we create. So what we are going to do is just go to here and create a calculated field. And the first one that we are going to create is the fixed LOD. So let's just call it fixed sales. And now we have to give a curly bracket. We have to use a key expression which is fixed, and then define the dimension around which we want to define the calculation, which is going to be subcategory in our case. Give a colon, and we're just simply doing a summation of sales. So just select that column and close your parenthesis. So now we have got the fixed expression where we are doing it across the fixed subcategory, that is our dimension. Then we have defined the sum of sales, and this contains errors that the fixed sales already exists. So okay, let's say fixed subcategory. Okay, so fixed subcategory, sum of sales. Okay, now let's create all the three level of expressions, the kind of expressions, and see how the results would vary. So next one is going to be include subcategory. Okay, and same syntax, include the keyword, define the dimension, colon, and then sum of sales, close it, close it. Okay, and then the third one is going to be the exclude subcategory. Exclude subcategory. Exclude keyword, then the dimension, which is going to be subcategory, and then the sum of sales, and then just close it. Okay. So now we have created the three kinds of LODs, three different kinds of LODs that can be created, and now we are going to include these LODs in our visualization to see how they are calculating the different values or the summation of sales. So fixed sales, okay, sorry, fixed subcategory, just add it over here. Then we have next one is include, or let's pull the exclude first. Exclude subcategory, and then we have the include. Let's just pull this here as well. Okay, so it has taken the form of a bar chart, which is also okay. If we bring exclude once again. Okay. So now we have different values, as you can see, for exclude, for fixed, and for include. And our visualization at this point of time includes the category and the subcategory. So now just to check whatever values we are getting and how they're related to the totals or subtotals that are there, let's just go to the analysis. Okay, let's go to the analysis, go to totals and add all subtotals. So we have the figures here as well. Okay, and now let's try to understand what is this way, what this data is indicating, and how these key expressions have changed the way the sum has been calculated or computed. The sum of sales has been computed. So now if we take a look here, let's start with the fixed subcategory. So fixed subcategory, we said that fix it across a subcategory dimension. Subcategory dimension is this dimension, and we can see that the values are same as the one for sales over here, right? So sales value are automatically calculated at a subcategory level because subcategory is included in the view, and that's why we have this these amounts which are same. You can see across all the subcategories the amounts are same as the ones which were calculated by the summation of sales, because we have fixed it across the subcategory dimension. Okay, now let's go to the include subcategory. Include subcategory, we said that include the subcategory dimension while making the computation. So whatever other dimensions are present in the view are included as well here. So category has been included, then subcategory, and therefore it is also having the same value as the sales, because again the computation is at a subcategory level. Now let's go to excludancy. Exclude is actually giving us the summation of values or summation of sales at a category level. So we can see that the summation of sales for the category is 59219, and that is the value that we are getting across all the records in this data visualization. And that is because in the exclude subcategory, we specified that exclude the dimension subcategory while performing the calculation. And this seems to be okay, because that's why it has skipped the subcategory granularity and aggregated at a higher level than what is present in the view. So it has aggregated at the category level. So the results seem to be correct so far, and they seem to be behaving the way we want it to behave. Now let's do one thing and add another level of hierarchy over here. So let's go above and add the region as well to this view, and now let's see what is happening. So if we add the region as well, then we can see that there are 4 regions: central, east, west, and south. Okay. Now for each region, the categories and the subcategories have been, so the data has been split up based on region and the categories lying within that region. Okay, so all 3 categories lie in each of the region. So the data basically has now been split by region as well. And now if we take a look at the figures, we have different figures across all the include, fixed and exclude computation. So now let's again go back and try to understand what exactly is happening over here. So let's go to the fixed one, which is the easiest to understand here. And we can see that fixed is 7445. So still the same figures as we were getting from earlier. So let's just duplicate this sheet to understand it better. So duplicate, and from this let's just remove region, right? Okay. So now in this view, what we were getting was 7445, 25, 155, 9578, whatever values we're getting in the view, which has category and subcategory. Now we have changed the view to have another level of hierarchy, which is region, but the values of the subcategories are still the same. For furniture and bookcases, the value remains static as 7445, even if I go to another region. So if I go to East region and check the values for furniture and bookcases, the fixed values, fixed sum of sales values, still 7445. Okay, and that is because the calculation is fixed along the subcategory dimension. When we specify a fixed LOD expression, it just takes into consideration the dimension that we have mentioned in the calculation when writing the calculated field. It does not care about any other dimension that is on your visualization. So whether you add a dimension which is above this level over here, so we have split it by region, so there's another dimension, and the fixed LOD is not going to care about that dimension at all. So it is fixed to the dimension that is mentioned in the LOD expression. That's why the value here remains static. Okay, now let's go to the include expression and see why the values have changed. Now we said the include subcat, when we wrote the include expression, we just mentioned that include subcategory when you are making your computations. So subcategory we can see has been included, but the data or the results have been now split by the region. And this is because the include expression will take into account all the other dimensions that are present on your view. So because the region dimension is now present on the view, while making the computation, it has taken into account region, category, subcategory. Based on these three dimensions, it has made its computation. Right? That's why we are able to see that the values are same as the sales, because it has taken into account all the different dimensions that are present on this visualization. Now, if we go to the exclude expression, okay, so the exclude subcategory, the values are fixed at 4011, and this 4011 is basically the sum of sales for each subcategory, right? So what has the exclude expression done? The exclude expression has still excluded the subcategory. So whatever are the summations or whatever are the values that we are getting over here and the exclude LOD expression, they have been computed at a region and category level. The subcategory which is present on the view has been skipped or has been ignored. So this is how the exclude category or exclude LOD expression works. It just excludes the dimension that we have mentioned while creating the LOD expression. So it has excluded subcategory and it has just created the totals at a region and category level. And that is why we have these figures just static over all the subcategories. Okay. Now, if we just go and remove the subcategory from the view altogether, okay, so before doing that, let's go back and include the subcategory so that we can have our comparisons. Okay, include the subcategories once again. Okay, and now let's duplicate this once again. Okay, and okay, so from this view, let's just go and remove the subcategories now. So when you remove the subcategories from the view, what we have left is the category and the region. So if we go back and try to check the values, so let's start with checking the values for the fixed subcategories. Fixed subcategory is fixed at a subcategory level, and we can see that the values are 59219 for furniture in the central region, 59219 for furniture in the east region, and so on. So if we go back to our previous sheet, we can see that 59219 is the sum of all the values which were computed at a subcategory level. So it is basically the sum of sales of all the subcategories for this particular category, okay, irrespective of the region. So that is what is happening over here. We have now excluded the subcategory from the dimensional view. So the fixed subcategory has been created or has been computed still as a sum of sales for a subcategory, and then because we do not have subcategory in the view, in the current view, it has aggregated it at a category level, but the region still is not coming into the picture, as we can see that the fixed values are the same across the region. Okay. Now going to the include subcategories. What has the include subcategory done? It has figures like 4011. So include, we mentioned that include the subcategory. So it has included the subcategory, summed it up at a category level, but it has also included the region in the view. So the region and the category and the subcategory, it has summed up at this particular grouping level, and then while presenting in the view, because the subcategory is not included in the view, it is aggregated up to the category level. So if you go back to the previous figure, we'll see that 4011 is the total for this subcategory for this combination of region and category. Okay, so if you go to another region and see the value has changed for the include LOD, not for the fixed LOD, because the region was not taken into account for the fixed LOD, but it has changed for the include LOD because it takes into account region or whatever dimensions are in the view. Okay. And now let's look at the exclude subcategory calculations. So they are also 4011, and this is easy because we just said that exclude the subcategory. So now subcategory is not in the view as well. So that's why the numbers are matching with this, because in any case it has excluded a subcategory while making its computations. It was already making the computations at a higher level of aggregation, which is category. So it has just computed it for category and then split the data by the different regions. So there's different data or different values for each different region. So one pattern that you can simply and quickly identify from this is that the fixed subcategory remains fixed across the dimension. So we can see that the fixed subcategory values do not change with dimension. For furniture category, the value is 59219, whether the region is central, whether the region is east, whether the region is south, or whether the region is west. Fixed across one particular dimension mentioned in the LOD expression. Include and exclude, on the other hand, might change with what is included in the view, what other dimensions are included in the view. So if you include other dimensions like region in the view, the data or the summation would be split across region as well. Okay. Exclude allows us to do it at a higher level of aggregation. Include, you can actually go down below at a level of detail or granularity of the view. So you can actually make your calculations or computations at a level of granularity which is not present in your visualization. So that is the difference between include and exclude. Okay, and fixed is different altogether. Fixed basically remains static across the dimension at which the LOD expression has been defined. Okay, so this is basically, even if you want to understand it yourself, then just do a basic table. Just create this basic table with sales and these different hierarchical values, and just analyze, and you'll be able to play around with this, and you'll be able to get a better understanding of how these are actually working in the backend and how the values are actually getting calculated. So just a simple table calculation, analyzing sales across these different, just create all these three expressions together and include them in the view to be able to analyze how the different values are changing. Okay, so let's go back to category, subcategory. Let's include region over here as well. Back again. We have region over here. Okay. Okay. Region. And now let's try to include actually one level down. Let's go try to go one level down and include product name as well. So product name. And now let's see what has happened. So now for different regions, different subcategories, different products, you can see that the exclude and include are still the same. The fixed is 7445. So fixed is again at the subcategory level, same values fixed, irrespective of the other dimensions. Still irrespective of the other dimensions, the product name is one more dimension that has been added to the view. Region is one more dimension that is already present in the view, but the fixed calculation does not care either about the product or the region. As you can see, these are fixed values across all these different products as well, right? The include and exclude, on the other hand, include subcategory, so subcategory is included and it has split at a product level now. So you can see that the include figures are same as the ones which are here, calculated automatically by Tableau at this particular level. So it is basically considering all the different dimensions that are present on this view. Okay, and then the exclude is also showing the same values, though it is ignoring the subcategories, but since these are distinct products for this furniture region, that's why the values are the same. If we had overlapping subcategories across categories, then the values would have been different because it was excluding subcategories, okay? Because they are static values, that's why the values here are same, okay? So if you have the now you can just see that the include one is the same. The exclude might have been different because it creates it at a high level of aggregation. But since our data is distributed like this, that's why the values appear to be same. But then include, where what is the use case for include? If the values are same over here, we can just drag and drop the sales over here, and Tableau would automatically sum it at the level which is present in the view. The include, we saw the use case was that it can calculate at a lower level of granularity. So if we just remove the product name and like, let's go and remove the product name and the subcategories and things like that. Okay, let's go over here. Okay, so we delete the subcategory, and still the calculation has been made at a subcategory level, though it has been aggregated, and we can see the summation at this level. Okay, so include, exclude basically can be used for many other calculations that you want to build. So these would be your underlying LOD expressions. On top of them, you would be building some other conditions that you would then use in the calculated fields and show in your visualization. But this is basically how they work. So if you want to just check out how they work, then go to your just include region, category furniture, include these three different values and just play around with them to see how the values would differ. So as you can see, they are all different values in this particular view. So this is the easiest view to understand how they function in the back end. Okay. Okay. So this is just for understanding how they work. Now let's look at one use case where we are going to use the LOD expression and calculate uh, or analyze data in a particular way from a business perspective. So what we are going to do is we are going to analyze the average sales. Okay. And what I want to do, I just don't want to create the average sales. I want to create the average sales per customer, and then I want to see my uh, average of the average sales per customer. So if I just bring the sales over here, and change it to average. It is just doing a summation of all the sales for that subcategory and then creating an average. I do not want that. I want the information as what is the average sales happening per customer, and then at an aggregated level I want to see the average of all the averages, not the average of the sum of the entire sales, but the average of sales per customer. So that is my requirement. I want to analyze my data by the average sales per customer. So let's see how we can build this. So we are going to create another sheet here. Excuse me. And then let's just bring on to our visualization subcategory. So let's just drag and drop the subcategory over here. And then we are going to bring in sales from the measures. So let's go and select sales from the measures. Okay. And then we are just going to say that we want the average sales. So just change this to average. Okay. So that is one thing we have got. We have got the average sales figure across these subcategories. Now, the way Tableau has calculated the average is basically it has summed up all the sales for this subcategory irrespective of the customer. So all the total sales, and then calculated an average on that sum of sales for that subcategory. But my requirement is to analyze the average sales per customer and then compare it with this average sales that is happening and try to identify that how much is a variance kind of thing between the average sales per customer and a customer sale that is actually happening. So we'll build the visualization and we'll better understand what we are trying to achieve here. So this is the first step. Just bring your subcategory to the rows and create an average sales computation over here. Okay. Now the next step is to create an LOD expression, because what I want to do is to calculate the average sales per customer. Now the customer itself is not in this visualization, so I cannot just build an automated aggregate function to create the average sales, because I tried doing that and I can see that it has created the average for the summation of and the entire sales across the subcategory. But I want the computation to be made at a customer level, customer which is not present in the view. That is one thing. And customer which is going to be a lower level of granularity than what is present, than the dimension that is present in my view, which is subcategory. So which one is the ideal LOD expression to be used in this case? Now we have two requirements: create an expression around a dimension not present in the view. So obviously we're going to create an LOD expression. And how do we decide which kind of LOD expression we are going to create? So our requirement is to go down the granularity level to a dimension not present in the view, which is our customer. So that is the use case for an include dimension, because we are going to create a LOD expression, or we are going to create a computation which is at a lower level of granularity than what is presented in the view. So again, go back to the steps of creating an LOD expression. Click over here, go to create calculated field and give it some name. So we are going to give it a name of average customer sales, and then follow the syntax. So parenthesis and include, then the dimension around which we want the computation to happen. So the dimension for us is customer. So we can either take customer ID or customer name. Let's take customer ID because that would be unique. Customer names might be duplicated. And then colon. And then what we are going to do is, how do you create average sales per customer? So for each customer, you have to sum up the sales for each customer and then divided by the total number of customers or something like that, right? So you have to first sum up the sales. So sum of your sales for each customer, right? And then we have to Okay, there's some errors. Let's check out the errors. Errors is that we have to close it with a parenthesis. Okay, so now this expression is valid. It is just calculating the sum of sales at a customer level. We want to get an average customer sales, so we are going to include the average function over here and then just wrap it around the average function. Okay, so now this is the expression that is going to give me the average customer sales. So the include expression, because I wanted the computation to be made at a customer level, which is a lower level of granularity, and then just take an average of that expression. So just say okay, and it would appear in my measures pane. So now we have the average customer sales created as well. So now the next step that I'm going to do is just bring this over here to my columns as well. So now I have two graphs that have been created, as you can see, and they have slightly different values, right? So you can see accessories, the average sales is 208 and the average customer sales is 249. Average sales here for appliances seems to be the same. For bookcases, again, there is some variation in the average sales per customer and the average sales that Tableau created over here. So my requirement is to look at the average customer sales compared with this total average sales that that has been created by Tableau. So now to make the comparison, what I'm going to do is I'm going to make this in some other form. So first thing I'm going to do is I'm going to put it as a dual axis. So I'm just going to pull this average customer sales over here and make it a dual axis. Okay. Now, as soon as I make it a dual axis, some data points start to appear over here. Next thing I want to do is I just want to synchronize the axis. So, okay, so it is already synchronized. So now I have my data points appearing like this. And next thing I want to do is go to average sales over here. Okay, on my marks pane. So average sales as computed by the by Tableau, and I want to put the customer ID on the, let's say, the detail over here. So now I have my calculations by the customer ID. Okay, so it would be calculating based on the customer ID for each customer, the average sales. If I put it on the detail tab, now what is happening is what I've done is I've added customer ID to detail. So whatever average sales I was getting earlier based on each of the subcategories, that was sum of sales across the subcategory and an average of that. Okay, now I've included customer ID to detail. So now I've got these different data points which are like small circles over here. So these are average sales for each customer. So now these are average sales of each customer that I can see over here with each data point. Okay, so you can see if I put it or hover over a data point, I can see the customer ID that has been associated with it and what is the average sales for that particular customer ID. Okay, so I have achieved the same purpose that I wanted to achieve earlier on, average sales by customer ID. Okay, but now what I want to see with this new aggregation LOD expression that I created, I want to show the average of the average customer sales. Okay, so what we're doing here is average customer sales. So average sales by customer by subcategory, right? That is what we want to show. So now these data points are showing the average sales for customer for this particular subcategory. But what is the total average on this subcategory based on these average sales per customer? So that is what we have computed over here using the LOD expression. So to just make it visible over here, let's go to the this one. Okay, so this one we had added the detail. Let's go on the marks pane to the LOD expression that we created, which is this one, and then let's change it to, let's say, a Gantt bar so it is easier for us to see. Okay, so now once you change it to a Gantt bar, okay, and now let's try to analyze. So we can see that for the subcategory accessories, the average customer sales, which is the average sales per customer by subcategory, is 249, and there are some customers which are lying below this point. There are many customers actually which are lying above this point. So these customers have made sales which is greater than the average sales per customer for this subcategory. So these are the customers that are profitable customers for us. They are making good sales. These are the ones that we probably need to focus on and make them to buy more products from us so that we can more sales for these particular customer IDs for the subcategory of accessories. Now, if we go and look at copiers, for example, now we can see that the average customer sales is over here, and we have a lot many customers which are below this average mark, and there's one customer which is far above this average mark, and that is why probably why we have the average mark over here. So if we like this way, if we just keep on going around the different marks over here, we will see that there are some categories. For example, let's say the furnishings category. So there are only a few customers who are buying less than the average. There are many customers who are buying more than the average sales for this category. So this is good. But let's say we have anyone which is kind of a loss making one. So this one, if you go to, let's say, bookcases, then there are quite a few customers which are lying below the average customer sales, and there are just a few which are lying above the customer sales. So probably we need to change our strategies for this particular subcategory and so on. Okay. So this is one of the use cases, and this is basically where you would use. And as we saw in this particular use case example, that they are basically underlying expressions. On top of that, you're building something. So it is not the dimension itself is not part of a view here. The calculation itself is an underlying expression on top of which an average has been calculated, and then that is the final thing that we are showing on the visualization. So the main use of the LOD expressions is to create these expressions that can then be used to show complicated measures on your visualizations, and to give you a flexibility to do it, just fix it to one dimension or go above and below one dimension. So that is why the LOD expressions come into picture, and that is all the use of the LOD expressions here. So this way you will find so many different use cases where you are using, but that would not be the final, the expression that you create, that would not be the final thing that you would be showing on your view. You would be doing many more computations on top of that and then using it to present some scenario. Okay, so there was a time when LOD expressions were not part of Tableau. So at that time, you had to write really complex table calculations or other kinds of calculations to come at the same level of detail that we are showing over here. But now with LODs, because you can just include a simple keyword and fix it to a particular dimension, or go to a level below or above the granularity, that is, it's so much easier to write those expressions over here. Okay, and okay, right. So one more thing that we can actually see, so many times actually when you are writing the include expressions, the same objective can be achieved writing a fixed expression as well. So in this scenario that we took, we just created the average sales per customer, okay, and we had something created over here. So let's remove the fixed sales from here, from this view, and try to write this expression, fixed expression once again. Okay, so we had the average sales. So let's go back to the create calculated field, and for the same thing that we created, so we created the average sales at a customer level using an include keyword. So now we are going to create average sales again at a customer level, but we are going to use a fixed keyword. So let's just suffix fixed so that we can identify it for our purposes, and use the keyword fixed, and we are going to fix it along the customer ID dimension, and the same thing we are going to do, which is sum of sales, and close this with a parenthesis, and now take an average of that. Okay, and now I have this measure created, which is average sales fix. So I'm just going to drag and drop it onto my axis again. And now let's see what are the results that I'm getting. So the results that I'm getting over here are very different from the results that I have got for the average sales. And why is that? Because the fixed expression has fixed all the computations across the customer ID. It has not taken into account subcategories, which is also a part of our view. Okay, so we have done a calculation at a lower level of granularity, but it has not taken into account the other dimensions that are present in the view, and that is the difference between the include and the fix. Now we could have achieved the same thing that we have achieved through the include using the fix. So we are going to go back to average sales fix, and we are going to edit this calculated LOD expression once again, and simply what we need to do is include whatever other dimensions are available on the view and we are doing our computations on. So we are just going to include subcategory over here. Okay, and say okay, and now you can see that our figures are same as the ones that were given by the include LOD expression. So now the fixed LOD expression can be written to serve the same purpose. So in this case, why not write a fixed LOD expression and why go for an include LOD expression? The result is the answer is simple, and it is simply that an include LOD expression is much simpler to write. It is much more flexible, because now if I want to include some other let's say other dimension on the view, the include LOD expression would dynamically change to take that dimension into account for the computations that it is making, whereas a fixed one will need to be changed. So when you want it to be dynamic, you do not want to have fixed, because then you would need to go back to the fixed LOD expression, include that particular dimension that you have included in the view to fix your calculations. Even if you're not doing that, if you are sure that you're not going to include any other dimensions at any other point of time and you just want to stick with the subcategories over here, even in that case include is better. And why? Because it was so much simpler to write than a fixed LOD expression. Include, you just need to mention which one you want to make sure at which particular level of dimension or granularity you want to make your computation, and it would automatically take into account any of the other dimensions that are present on the view. For making the same computation using the fixed LOD expression, we have to explicitly mention all those dimensions in the expression. And if there are multiple dimensions, it would make it a very big expression. Okay, that's why the include ones are easier to write and can be preferred over a fixed LOD expression in scenarios or use cases like this. Fixed LOD expression in itself has a different use case that cannot be achieved by any other include or exclude. So in those cases, there's no other choice but to use the fixed LOD expression. But in these cases, we can go with include. Okay. So the idea or the point that I'm trying to make here is that whatever expressions you're writing using the include keyword, many times they can be written using the fixed key expression as well. But the include is easier to write and simpler to maintain, and that is why we can prefer include over fix in those scenarios.